Hello everyone, welcome to memoneet. This is Aprachita, your chemistry SME, and I welcome you with another video solution. So I hope you people performed well in the BPT 15. So today I am back with the video solutions for the BPT 15. In case you people have not understood any of the questions, so you can understand the solutions from here. Okay. So in this test, basically all the chapters were covered, which have been covered till now in all the tests. So I hope it was pretty easy for you to solve these questions because these questions have been solved earlier as well. Okay. So the very first question for chemistry, this is your question number 51. 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. Concentration of the solution is. So here you just need to find out the molarity of the particular solution given. The number of molecules of urea are given. Okay, so you know that molarity. What do you mean by molarity, students? It is the number of moles of solute divided by volume of solution in liters. Okay. So in this question, you have been given the number of molecules. So firstly, you will find the number of moles of urea. So you know from the molecules, the number of moles are you. How will you find it? By dividing it with the Avogadro's number. Okay, so divide this value with Avogadro's number and you will get 0.001 moles. Now you have got 0.001 moles. Volume is 100 ml. So 0.001 divided by 100 ml. So we have to take volume in liters. So we'll multiply it by 1000 to convert it to liter. So it will come out to be 0.01 molar. Simple, right? Very simple question. Answer is option number 4. Okay. Next question, which of the following pairs of compounds illustrates the law of multiple proportions? Okay. So if I talk about law of multiple proportion, so you know when two elements combine with each other to form more than one compound, then what happens is the weight of one element that combine with a fixed mass of other, they are in simple whole number ratio with each other. So here you can see SnCl2 and SnCl4. So the ratio in this case is 119 is the mass of 10. Okay, and for chlorine here you can take 2 into 35.5, 4 into 35.5. Okay, so the ratio will come out to be 1:2. Means the fixed mass of tin, which is 119, it is combining with chlorine, which is in simple whole number ratio, which is 1:2. So the answer is going to be option number 4. Next, which of the following has maximum number of molecules? Again, students, if you want to find out the number of molecules, try to find out the number of moles. Okay. So when you find out number of moles, you will get the number of molecules. So 7 gram of nitrogen. So nitrogen has atomic mass of 14, but here nitrogen N2 is given. So the number of moles will be 1/4 moles. Okay. Now 2 gram of hydrogen, 2 divided by, for hydrogen the molar mass will be 2 again, so 1 mole. 16 gram of NO2. So for NO2 the mass will be 46, right? No? Yeah, NO2 is there na, so 46. And again for 16 gram of oxygen, so again 16/32, which is 1/2. Now from here it is also less than 1 mole only. So you can see that the maximum number of moles is in 2 grams of hydrogen. So you just don't have to find out the molecules in this case. Just see which one has a maximum number of moles. So hydrogen has maximum number of moles in this case. So you will be getting 2 grams of hydrogen as the answer. Okay. Next up. Question number 54. The relative lowering of vapor pressure is equal to the ratio between. Okay. So students, you know that the relative lowering of vapor pressure. So if I talk about the vapor pressure like this, P naught minus P upon P naught. Okay. So it is equal to the mole fraction of solute. This we have studied in solutions chapter, that it is equal to the mole fraction of solute. Okay. So mole fraction of solute, let's say if 2 Na and Nb are there, okay. So Nb is the number of moles of solute. So mole fraction of solute means number of moles of solute divided by total number of moles. So you can say solute molecules to the total molecules in the solution. The answer is option 2. Okay. So I think it's clear. Question number 55. Which of the following binary mixtures have same composition and liquid and vapor phase? So students, you know the mixtures that have same composition and liquid and vapor phase are known as azeotropes. Okay. So they are called azeotropes or constant boiling mixtures because they boil at the same temperature. So water and nitric acid and water and ethanol are non-ideal solutions, and they are the examples of azeotropes, whereas benzene, toluene, n-hexane, n-heptane, they are your ideal solutions. So they will not be azeotropes. So the answer will be B and C, that is option number 3. Now question number 56. Which of the following statement is false? Units of atmospheric pressure and osmotic pressure are same. This is true because yes, it's just pressure only na, so the units would be same. Next is in reverse osmosis, solvent molecules move through a semi-permeable membrane from a region of higher concentration of solute to a region of lower concentration of solute. So what happens in reverse osmosis? So students, here it has to be from a region of lower concentration of solute to a region of higher concentration of solute. So then this statement would be wrong, because in reverse osmosis what happens is that solvent molecules will move from the solution back to the solvent, means from a region of higher concentration of solute, like from the solution, to the region of lower concentration of solute, means where the solvent is present. So that's why we are saying this is a wrong statement. Value of molar depression constant depends on nature of solvent. This is true. And relative lowering of vapor pressure, it's a dimensionless quantity. This is also true because we are talking about relative lowering. So it will be a dimensionless quantity. Now next question is, strontium has an atomic number of 38. An isotope of strontium has 50 neutrons. What is the mass number of this isotope? So this is very simple because you know students, mass number, okay, A is equal to the number of protons plus neutrons. Now the atomic number is 38. Now atomic number 38 means number of protons will also be 38 and neutrons they have given 50. Okay, so it will come out to be 88. So means the mass number will be 88. The answer is option number 3. Okay. Next is, the number of neutrons in an atom can vary. Atoms with same number of protons and different number of neutrons are called. So you know, if there are same protons, okay, same protons means students, the atomic number will be same. Okay, same atomic number, but different protons are there. Different protons means when we will add them, we will get different mass number. So the elements having same atomic number but different mass number are called isotopes. So the answer for this question is going to be isotopes, because isotopes are the ones which have different number of neutrons in them. Okay. Next is question number 59. Let's see. It says, which of the following statements about electrons is not true? Electrons are negatively charged particles. This is true. They have very small mass as compared to protons and neutrons. This is actually true, means you can say they have a very small, okay, let's see, exact location of electron cannot be determined with certainty. Fine. Electron participate in chemical reactions by forming or breaking bonds. This is also true. Okay, so electrons are the ones that take part in the chemical reaction. So in this case we can say electrons are actually much lighter than protons and neutrons. Okay, the mass of electron is significantly smaller, but it is not zero. Okay, so that's why we will say ki second equation is not, a second statement is not true. So the answer is option 2. Okay. Question number 60. Which of the following statement is not true about Lewis structures? So now we are talking about Lewis structures. They represent the arrangement of valence electrons around the molecule. Yes, students, Lewis structure may we just write the number of valence electrons. Like for carbon we have 4, so I'll just show 4 dots by showing 4 valence electrons. They can be used to predict formal charge. Yes, we can find out the formal charge of any atom in a molecule using Lewis structures. They always show a double bond between two oxygen atoms in a molecule. See, this is not actually a correct statement because always show a double bond, we cannot say that, right? They actually show the arrangement of valence electrons. हाँ, oxygen के case में it's double bond, but they don't guarantee a specific type of bonding. Okay, they can depict like lone pairs, single bonds, everything also. Okay, they don't necessarily depict the three-dimensional structure of the molecule. This is also true because it's not necessary that they will tell you about the three-dimensional structure of the molecule. So the answer is option number 3. Next, bond order is a concept used in valence bond theory to describe the strength and stability of a covalent bond. Okay. Triple bond has a bond order 3. Which of the following molecules have highest bond order? Okay, so if I talk about the bond order in this case, okay, so for nitric oxide, students, the bond order is going to be 2.5. Okay, it is calculated. For carbon dioxide there are two double bonds, right? So its bond order is 2. For nitrogen there exists a triple bond between the nitrogen atoms, so bond order is 3. And for oxygen again there's a double bond, so bond order is 2. So highest bond order will be in the case of nitrogen, so answer is option number 3. Okay. Next, which of the following has the maximum bond order? Again, you need to find out the bond order in O2 minus, O2 plus, O2 minus and O2. So you will be using the molecular orbital theory for answering that. So you know bond order is equal to half the number of electrons in bonding orbital minus the number of electrons in anti-bonding orbital. So once you do this, you will be able to find the bond order. So students, if I talk about the bond order of oxygen, so it's 2, okay. Then if I talk about O2 minus, then it is 1.5. O2 2 minus is 1, and for O2 plus, okay, positive charge, the bond order will be 2.5. So the highest bond order is for O2 plus. The answer is going to be option number 2. Okay. Next is given below are few statements regarding electrode potentials. Mark the correct statement. Potential associated with each electrode is called this electrode potential. This is actually true. Negative E naught means the redox couple is a stronger reducing agent than hydrogen couple. This is also true if there is negative electrode potential. So it means the redox couple is a stronger reducing agent than hydrogen couple, and a positive E naught value means the redox couple is weaker reducing the agent than hydrogen couple. So it means all the three statements are true. So answer is going to be option number 4. Next is question number 64. In the electrolysis of molten sodium chloride, the products formed at the anode and cathode are, okay. So if I talk about the electrolysis of your sodium chloride, so what happens is chloride ions will move towards the positive electrode, which is your anode, and sodium ions, they gain electron and they move towards the cathode. Means at cathode sodium metal will be formed and chlorine gas will be liberated at the anode. Okay, so sodium metal at the cathode and chlorine gas at the anode. So here write cathode and anode respectively. So cathode पे sodium and anode पे chlorine. Answer is going to be option number 1. Okay. Now students, next question is question number 65. It says in the galvanic cell, the half cell reaction with the more negative centered electrode potential occurs at the anode cathode, both anode cathode, and it depends on the reaction. Now you know that the half reaction which has a more negative standard electrode potential, it will occur at the anode, because standard electrode potential, it is the reduction potential also. It reflects the tendency of a half reaction to occur as reduction, means gaining electron. More negative E naught means the weaker tendency to undergo reduction. It means oxidation will happen, and this will be happening at the anode. Okay. See, that's what we have explained you here, that if a reaction has more negative E naught value, means it is less enthusiastic about gaining electrons. So it means it gets forced to lose electrons, and loss of electrons will be happening at the anode. So if E naught value is a negative value, so it will be happening at the anode. The answer is option 1. Okay. If you have more positive value, if they can ask you about positive also. So if E naught value is more positive, so it will occur at the cathode, because there will be more tendency to undergo reduction, means to accept the electrons. Okay. Now X is a state function and intensive property. Y is a state function and extensive property. Now what can be X and Y? So pressure, students, it's a state function and intensive property. Temperature is also a state function as well as intensive property. Okay, it is not extensive. It is independent of the mass, or independent of the amount of the substance. Okay, so they are intensive properties. Then if I talk about volume, volume is an extensive property. Internal energy, it's an extensive property as well. They will depend on the amount. Okay, so in this case, second option is also not correct. Then enthalpy, enthalpy is a state function and extensive property. Temperature and is all an intensive property, so that also doesn't fit. If I talk about the fourth one, pressure is an intensive property and internal energy is an extensive property. So yes, the answer for this question is option 4. Next is question number 67. So following reactions are given to you. Water is converting from liquid to gaseous state. Then methanol, burning of methanol happens. Delta H values are given to you. Okay, so what you have to do is, what is the delta H for second reaction if water vapor instead of liquid water is formed as the product? Okay, instead of liquid water, if we get water vapor as the product, so then we have to find out the delta H value. So for first reaction and second reaction, delta H values are given. Now if I multiply this equation equation 1 by 4, okay, so I have to multiply delta H also with 4, so I'll get 176. Okay, now this is H2O, liquid to gas. Okay, now what we will be doing here is, I'll be adding both the equations. If I add both the equations, this H2O liquid would cancel out. You will be left with H2O gas. Okay, so when you add it, it comes out to be minus 1277 kilojoule. Okay, so here it will be gas. Alright. So yes, the answer is option 3. Next is question number 68. Consider the reaction when 4 gram of iron is burned to ferric oxide at constant pressure. 29.28 kilojoule of heat is evolved. The enthalpy of formation of ferric oxide will be. So in this question, you have to tell the enthalpy of formation of ferric oxide. Okay. So what is the weight of iron burned? 4 grams, and the heat liberated is 29.28 kilojoule. And you know atomic weight of iron is 56. Now in ferric oxide, which is your Fe2O3, 2 moles of iron means 112 grams of iron will be burnt. So when 4 grams of iron is burnt, this much heat is liberated. So 112 will be burnt. So we can calculate it for 112, means 29.28 divided by 4 into 112. So it will be 1819.8 kilojoule positive. So this much heat will be liberated. Okay, next question students, question number 69. Enthalpy of combustion for methane, graphite and dihydrogen are given. You have to find enthalpy of formation of CH4. So from these equations now you have to add, subtract these things, and then you will be able to do it. So for enthalpy of combustion of methane, it's there, graphite and hydrogen. Now here students, you just add these equations. We have multiplied the third equation by 2. Okay, now when you will be adding it, so this 2H2, so here 2H2 is there, so this 2O2 and O2 will cancel out. Okay, and like when we will be reversing the equation. Okay, so from here, now this 2H2O and 2H2O will also cancel out, because we are reversing the first equation. Okay, and from here CO2 and CO2 will also cancel out, so we will be left with C plus 2H2 gives CH4. So the answer will come out to be minus 74.8 kilojoule per mole. Next question. Combustion is an exothermic process, combustion is a spontaneous process. So students, you know, in this combustion, products are more stable than reactants, so their energy is much lesser than the energy of the reactants. So products will be more stable and exothermic for all the combustion, and yes, the reaction will be a spontaneous reaction or a spontaneous process. So the answer is option 1, that is both assertion and reason are true, and reason is the correct explanation of assertion. Now, for the reaction A plus B gives 2C plus D, which one is the correct, incorrect statement? So, you need to write the rate of the reaction, which is minus of dA upon dt, means rate of disappearance of A and B, and half of appearance, because C and D are the products now, and rate of appearance of D and C and D. So rate of disappearance of A is equal to rate of disappearance of B. This is true. Rate of disappearance of A is equal to rate of disappearance of D. This is also true. Rate of disappearance of B is 2 multiplied by rate of appearance of C. No, it's not 2. It is half. Okay. So this is wrong. Rate of disappearance of B is half multiplied by rate of appearance of C. This one is true. It means the third statement is not true. Okay. Question number 72. The rate constant of a first order reaction whose reaction rate is 0.06 molar per second at 10 minutes and 0.02 molar per second at 20 minutes would be. So we have to find out the rate constant. So formula for rate constant would be 1 upon T2 minus T1, because we are talking about first order reaction, log of R1 upon R2. So all the values are given, time is given, rate is given. Just solve it and we'll get the answer 1.83 into 10 to the power minus 3 per second. Okay. Next is, using the data given below, the order and rate constant for the reaction would be. So you have to find out the order and rate constant for the reaction. Okay. Now here you can see, when we are doubling the concentration, okay, the rate of reaction becomes 4 times. Okay, so if the rate of reaction is becoming 4 times, means this is a second order reaction. Okay, order is 2. Now we need to find out the rate constant also. Okay, so R will be K into A square. So you can put any values, 0.020 K into 0.10. We can take the first value. So from here, the value of K will come out to be 2 liter per mole per second. Okay. So yes, the answer is option 1. Because from the rate only we get to know na ki it's a double, that is your second order reaction. Next up, which of the following reaction is a true first order reaction? Okay. Now, if I talk about alkaline hydrolysis of ethyl acetate, acid catalyst hydrolysis of ethyl acetate, these will be pseudo first order reaction, because यहाँ पर hydrolysis is happening and the concentration of water will be in excess. So the concentration of water we will be taking as constant. Okay. So it will become pseudo first order reaction. If I talk about decomposition of N2O, so it will be N2 plus half O2. So the rate of the reaction will be N2O raised to the power 1. So N2O raised to the power 1 means the order of the reaction is 1. Next is a zero order reaction is the one whose rate is independent of. So students, you know that the zero order reaction, okay, for any zero order reaction, the rate of the reaction will not depend on the concentrations of the reactants, okay, because the rate will be given by K. A means concentration raised to power 0. So answer is going to be option number 2. Now, next is which of the following complexes show geometrical isomerism. So, the complexes, octahedral complexes having formula MX2L4, which means 2 ligands are same and 4 are other. So, in this one, the 2 ligands X, like this, I can show you. So, they can be trans to each other, like this. Okay, this is the trans form. And they can be cis to each other also, like this. So this cis-trans isomerism is known as the geometrical isomerism. So this type of complex is the first one only here. So it's option number 1. Question number 77. Which of the following statements are true and which are false? Statement 1 is NiCl4 is paramagnetic while NiCO4 is diamagnetic. So yes, in the nickel chloride, tetrachloride, we have a tetrahedral geometry which has a high spin complex. 2 unpaired electrons are there, means it is paramagnetic. Now in CO means carbon monoxide, these carbonyl ligands, they are strong field ligands and pairing of electron will happen. So diamagnetism will happen. So this is true. Statement 1 is true. Statement 2, spin only magnetic moment for M and Br4 2 negative. Now bromide is a weak field ligand, no pairing will happen. Here manganese is in +2 oxidation state, means it is having 5 unpaired electrons. Okay. So 5 unpaired electrons, you can find out the magnetic moment using the formula square root of n into n plus 2. So it's coming out to be 5.9 Bohr magneton. Excess copper and iron are removed by chelating ligands D-penicillamine and desferoxyamine B via the formation of coordination compounds. So yes, these are your chelating ligands which are used in chelation therapy to remove excess metal like copper and iron from the body by forming stable coordination compounds with these metals. So it means this is also true. This statement is kind of a use of coordination compounds, okay? The answer is option number 2. All the statements are true. Now, which of the following pairs are ionization isomerism? Ionization isomers. So, ionization isomers are the ones which have same composition, but they will yield different ions when they are dissolved in the solution. Okay. So, means outside the ionization sphere, there will be different ions. If I look at this compound, here sulfate anion will be there, but if I like interchange bromide and sulfate, so in this case you will get bromide ion, okay, because outside the coordination sphere we have different ion here and here. So it means they will be forming ionization isomers, okay. So the answer is option number 2. Next is FeEn thrice 3 plus is dash stable than FeNH36 3 plus. So of course it will be more stable. Why? Because we have ethylene diamine ligand, okay. Ethylene diamine ligand, you know, it is a bidentate ligand and ammonia is a monodentate ligand. So ethylene diamine may, because of the chelation or the chelate effect, it will be more stable. This compound will be more stable, because try to keep that in mind whenever we are having this ethylene diamine, there will be chelation, and because of this chelate effect it will be more stable, okay. Next, the values of crystal field stabilization energy, okay. For high spin d metal ion in octahedral and tetrahedral field are, so if I talk about this thing, your high spin means weak field complex will be there. D-metalline in octahedral field, and so what happens is we get splitting T2G and EG orbitals splitting will happen. So for the octahedral field it is minus 0.4 delta naught, and for tetrahedral it is minus 0.6 delta T. Okay, so the answer is option 4. So this is the crystal field splitting energy for your octahedral and tetrahedral compounds. Next, question number 81 is given. So there is a compound given. Okay. The above reaction is an oxidation reaction. Why? So now we are having potassium ferrocyanide and potassium ferricyanide. So basically the given reaction is an oxidation reaction because the removal of electropositive element potassium from potassium ferrocyanide. Okay, so you can see that there is a removal of potassium from potassium ferrocyanide, and it is an electropositive element. So whenever there is a removal of electropositive element, we will be calling it as oxidation reaction. Okay. Next is question number 82. We have to match the columns. Okay. So what is happening in magnesium plus oxygen? So here addition of oxygen is happening. Okay. So for A it's R. Now magnesium and chlorine gives magnesium chloride. So addition of electronegative element, which is your chlorine, it's happening. So for B it's S. Okay, H2S plus O2 gives sulfur and H2O. Now hydrogen atom lose electrons and are removed from the elemental form. Okay, means there is removal of hydrogen that is happening. So for C it's P, and for D option, potassium, which is electropositive, forms a compound with water and oxygen, removing it from its elemental form. So means removal of electropositive element is happening. So D is Q. So AR, BS, CP, DQ, answer is option 2. Okay, everyone. Question number 83, when SN2 positive changes to SN4 positive, what is happening? So you know students ki SN2 positive will lose 2 electrons and then it will convert to SN4 positive. Okay, and loss of electrons is happening. So loss of 2 electrons, it's an oxidation reaction because यहाँ पर oxidation state is increasing. Earlier there was loss of 2 electrons, now 2 more electrons are lost. So answer is option 1, it loses 2 electrons. Next question 84. In which of the following compounds the oxidation number of iodine is fractional? So in I3 minus, okay, I3 minus may if I want to find out the oxidation number, it will be minus 1 by 3. Okay, so in this case the oxidation number of iodine is fractional. The answer is option 2. Next question is, students, which of the following reaction are disproportionation reactions? So disproportionation reactions are the ones in which there is simultaneous oxidation of one species and reduction of the other same species, okay, in that particular reaction. So in this case here you see the reaction of copper plus, so here it is changing to copper 2 plus and copper 0. So in this case there is oxidation of copper happening from copper plus to copper 2 plus. Okay, this is oxidation that is happening, and from copper 2 plus to copper reduction is also happening. Okay, so B is a disproportionation reaction. Okay, now if I talk about the first reaction, from here the oxidation state of iodine, the oxidation state is increasing from +6 to +7, that is for manganese. From +6 to +7 it is increasing, and it is also decreasing from +6 to +4. So it is also a disproportionation reaction. So A and B both are your disproportionation reaction. The answer is option number 1. Okay. Next is section number B. 100 ml 10 to the power minus 4 molar HCl is mixed with 200 ml of 10 to the power minus 4 molar NaOH, and the volume is made up to 1 liter. So final pH of the solution would be. Okay. So firstly we need to find out the concentration of the resulting solution. Then we will be able to calculate the pH, right? Now HCl and NaOH both are strong acids and bases, so obviously you will be getting a neutral salt. They will react completely, that is water and salt would be formed. Okay, now what is the number of moles of HCl? So it will be volume multiplied by the concentration, right? Now because concentration is number of moles upon volume. So if I have to find out the number of moles, so it will be concentration multiplied by volume. So concentration is 10 to the power minus 4 molar and 0.100 liters. Okay, it is there 100 ml, no? So 0.100 liters. So it will come out to be 10 to the power minus 5 moles. Then if I want to find out the number of moles of NaOH, so volume was 200 ml and concentration was same. So it will be 2 into 10 to the power minus 5 moles. Now they will be reacting in 1:1. Alright, 1:1 में react करेंगे. So means the moles of NaOH will neutralize HCl completely, but after that you will be left with the number of moles of NaOH because they are in excess. Okay, the number of moles of NaOH are in excess. So 10 to the power minus 5 moles to react हो जाएंगे, but again 10 to the power minus 5 moles of NaOH would be left. Okay. So this much moles of NaOH are left. Now let us find out the concentration for the resulting solution. So concentration of NaOH क्या होगी? The volume is 1 liter ना. So number of moles of NaOH क्योंकि ये जो resulting solution बनेगा वो तो neutral होगा, but again the pH will be because there will be unreacted moles of NaOH. So number of moles of NaOH divided by volume of solution in liters. So means the concentration is 10 to the power minus 5 molar. Okay. Now it is a strong base. It will dissociate in water to release your hydroxide ions. So POH will be minus log of OH concentrations. So it will be coming out to be 5. So if POH is 5, so we know that pH and POH is 14. Sum is 14. So from here the value of pH will come out to be 14 minus 5, that is 9. Okay. Question number 87, reaction for which Kp is greater than Kc is, so again if the delta Ng means the number of moles is greater than 0, then Kp will be greater than Kc because Kp is greater than Kc RT raised to the power delta N. So if delta N is greater than 0, means if it is positive, then Kp will be more than Kc. So for first reaction the number of moles are same, means it's 0. So यहाँ पे Kp would be equal to Kc. In the second reaction, number of moles on reactant side are 2 and number of moles on product side are 4. So delta N क्या हो जाएगा यहाँ पर 2. Okay, 1 plus 3, 4 and minus 2. So for second reaction, Kp would be greater than Kc. Okay. So यहाँ पर in third reaction, delta N जो है वो negative आएगा, which is minus 1. And again, for fourth reaction also delta N is negative, that is minus 1, 1 minus 2. So delta N is positive only for the second reaction. So it's option 2. Now let us see another question, question number 88. Which of the following statements are correct? So here N2O is changing to N2O4. At low temperature, intensity of brown color decreases. So what happens is the exothermic reaction shifts to right. Okay, because if I am talking about this low temperature, here heat is, it's an exothermic reaction. Okay. So if we are talking at low temperature, according to Le-Chatelier's principle, the exothermic reaction shifts to right. Means if it shifts to right, the density of brown color will decrease. This is true. Next, equilibrium constant for a given reaction increases as the temperature increases, because equilibrium constant for exothermic reactions, it decreases with increasing temperature. So this is not true. At low temperature, brown color intensifies. This is wrong. Just now we have seen कि at low temperature brown color will reduce. And on increasing pressure, reaction goes in forward direction. This is true because there are fewer number of moles on right hand side. So if you are increasing the pressure, the reaction will move to right hand side. Okay. So A and D only are correct. Yeah, A and D. Okay. Question number 89. If at 25 degrees Celsius the Ka is given, then hydrolysis constant for NaX would be. Okay, so K for Hx is given. So hydrolysis constant for from here you can find it out. So it will come out to be option number 2, 10 to the power minus 9. Okay. Next question number 90. Students, on addition of ammonium chloride to ammonium hydroxide, what will happen? So if we are having ammonium hydroxide solution, so it will be giving you ammonium ions and hydroxide ions. Now I am adding ammonium chloride to it. So this ammonium chloride will also provide ammonium ions to it. Okay. And because of chloride, so because of the ammonium ions, now there will be more ammonium ions, so it means the reaction will proceed in the backward direction because of the common ion effect. So dissociation of NH4OH will decrease, means the concentration of hydroxide ions will decrease. The answer is option 3. Because of common ion effect, we are providing more ammonium ions. If more ammonium ions are there which are on the product side, so the reaction will proceed to the backward direction. Okay, and if it is proceeding to backward direction, means less dissociation would be there and the concentration of hydroxide ions will decrease. Now question number 91. Ionic product of water will increase if we, so ionic product of water is like 10 to the power, if I talk about Kw, so it's 10 to the power minus 14 at 25 degrees Celsius. If we are increasing the temperature, Kw value will increase. So the answer is option 4. Okay. Next 92nd question. For the reaction, 3 reactions are given, equilibrium constants are given. We need to find the relationship. Okay. Now 3 equations are given. Okay. So let's say if we are adding equation 1 and 2. Okay. So if you people are adding equation 1 and 2, what will happen? CO and CO will cancel out. So we will be left with CH4 plus 2H2O gives CO2, and so it's H2 now here, 4H2. So we are adding equation 1 and 2 and we are getting equation number 3. Okay. So it means K3 will be equal to K1 multiplied by K2. So answer will be option 3. Because addition के बाद हमें equation मिली है ना, we have got the equation after addition of these two equations. Now question number 93. N2 plus 3H2 gives 2NH3. Now addition of small amount of inert gas at constant pressure will shift the equilibrium to which side? Now if we are adding inert gas at constant pressure, okay, so it means it will increase the volume. Okay. Now if increase of volume is happening, equilibrium will shift in the direction where number of gaseous moles are more. Okay. Means in the left hand side on the backward direction. So answer is option 1. So these things are happening in accordance with the Le Chatelier's principle. Okay. Next question, students. Compound A used as a strong oxidizing agent is amphoteric in nature and it is part of lead storage batteries. So out of these compounds given to us, PbO2, that is lead oxide, it is amphoteric in nature. Okay, it is a strong oxidizing agent and it is also one of the component of your lead storage batteries. So the answer is option number 1. Question number 95. One of the byproducts formed during the recovery of ammonia from solvay's process is. Okay, so this is also called as the ammonia recovery. So calcium hydroxide, okay, calcium hydroxide is reacted with the ammonium chloride, which is separated out of your carbonating tower by filtration. Okay, so once we react this, so we get calcium chloride, ammonia and water. So the ammonia is recycled back into the process to form ammoniated brine, and calcium chloride is the one that we are getting as the byproduct of the Solvay's process. So the answer is option number 3, that is calcium chloride. Okay, now next is a number of halogens forming halic 5 acid is. So you can see that the number of halogens that are forming are chlorine can form, okay, bromine can form and iodine can form. So it means 3 halogens can form this. So answer is option number 3. Question number 97 it is, the small increase in covalent radii from silicon to lead is due to the presence of. Now there is this small increase. Okay, now you know when you move down the group there should be considerable increase of atomic radii because of the increase in number of shells. Carbon to silicon, yes, there is a considerable increase, but when we are moving to lead, then there is a small increase only because completely filled d and f orbitals are present. And because of those completely filled d and f orbitals in heavier members, they have actually a poor shielding effect. Poor shielding effect is there, so it means the outer electrons are held tightly by the nucleus because of the poor shielding effect of d and f orbitals. So for f orbitals we call it as lanthanide contraction also. So answer is option 2. Which of the following is not an allotrope of carbon? This is very easy. Diamond, graphite and fullerene are allotropes of carbon. Soot is not an allotrope. The answer is option number 3. Compounds formed when noble gases get entrapped in the cavities of crystal lattices of certain organic and inorganic compounds are known as. So these compounds are known as clathrate, students. Okay, when noble gases they get entrapped in the crystal lattices of your organic and inorganic compounds. One last question. Formation of pH 4 plus is difficult as compared to NH4 plus. Now you know, students, that in the case of ammonia, okay, there is one lone pair. Okay, one lone pair is there like this, and it is directional because it is present in the hybrid orbital. Okay, sp3 hybridization is there in this case, and nitrogen is not having any vacant d orbital. Okay, so this electron cloud is concentrated over the nitrogen atom only. So this electron cloud is readily available for the proton. Okay, so it coordinate bond is formed and ammonium ion is formed. Okay, but in pH 3, that is your phosphine, the lone pair is present in s orbital and it's non-directional. Okay, यहाँ पर it was present in hybrid orbital, that's why it was a directional. Okay, but s orbitals, you know, they are non-directional, so overlapping tendency is very less, okay, as compared to your ammonia. And moreover there are empty d orbital also, so that is why here the lone pair is not concentrated over the phosphorus. So that is why it is difficult for phosphine pH 3 to form pH 4 plus or to donate its lone pair of electron. Okay, so we can say the answer is lone pair of phosphorus resides in almost pure s orbital. Okay, whereas in ammonia it is in the hybrid orbital. So students, I hope all the questions are clear to you, whatever we have discussed in this PPT 15. If in case you are having any doubts, you can let us know through the comment section. We will see your comments and we will try to resolve your doubts. Okay. So try to revise all these questions once again, because these are important questions that we have taken from NEET point of view. Okay. So thank you so much students. We shall meet in the next lecture. Until then, thank you. Bye-bye.